All right, welcome back. Hononegah Honors Algebra 2. Section 5.2, properties. We're going to be 2 days on this, so this is 5.2 day 1. Properties of rational exponents and radicals. These properties are the exact properties you did back when you were in Algebra 1. The trouble is that we're throwing fractions at you, and as soon as you start throwing fractions, things start getting more complicated for people. Okay, some of you are what I refer to as fractionally challenged. Okay, it's an ailment that some of you have. So the next slide is off script. Okay, it's not in your notes. You're just going to watch. Power of a power. Back when you were in Algebra 1, if you had x squared times x to the fourth, you would add the exponents and get x to the sixth. So that's product of powers. Next, power of a power. So if I had x to the third and I raise that to the fourth, I take the two exponents and I multiply them together. So that's x to the 12th. Power of a product. What that means is if I had, let's say, 2x to the fourth power and I raised it to the third. I'm going to put that to the third just to make it a little bit more challenging. Means that you take 2 to the third power and x to the fourth to the third power. So you end up taking each of them inside the parenthesis to that power. So it's kind of like distributing, but it's not. But you're taking each one to that power. Now, negative exponents. So what happens if I had like a negative power? Well, that means reciprocal. We kind of talked about that in section 5.1. Zero exponent. That means anything to the zero power is 1. Quotient power. So what if I had x to the fifth being divided by x to the second? Well, you take the two exponents and you subtract. And then power of a quotient, meaning if I had a fraction, x to the fifth, and I raise that to the power, you are technically taking the power of the top and the power of the bottom. So x to the third raised to the second, x to the fifth. Now this one can be simplified because I ultimately can subtract the exponents. But this is back when you were in Algebra 1. So now, what's it going to look like now? The only thing that's different is you are now using fractions. So if the bases are the same and you are multiplying, you can add their exponents. If I have a power that is raised to a power, I multiply the powers together. If I have more than one item being raised to the power, I take both of those and raise it to the power. Negative power means 1 over. Anything to the zero power means 1. If I'm dividing, I can subtract their exponents, and if I have a fraction raised to an exponent, then both the top and the bottom of the fraction are then raised to that exponent. So those rules that you did back in Algebra 1 still apply now, even if you have fractions involved. So 13 to the 1/3 times 13 to the 1/6. Remember, if you are multiplying two like-based items together, you don't change the base and you just add the exponent. So 13, and I'm going to take 1/3 plus 1/6, because again, when you multiply, you add exponents. So that's 13 to the 3/6, or 13 to the half. So, and again, I can prove this on a calculator if you want to. Take 13 to the 1/3 power and times it by 13 to the 1/6 power, and then do 13 to the 1/2 power, and it's going to end up being the exact same decimal. Anytime you have more than one item in a parenthesis raised to an exponent, and it's a multiplication symbol in the middle, then both items can be raised to that exponent. So now, 5 to the 1/5 raised to the 5th. I would multiply the two together and get 5 times 8 to the 5/4. Now, because the bases are not the same, that's as far as I could go on that one. Next one. So I'd have, if I took both of these to the negative 1/3 power, I get 12 to the negative first and 9 to the negative first. Well, that's 1 over 12 times 1 over 9, and ultimately I can multiply those two together because they're both just to the first power. So anytime you have a negative power, it means reciprocal of. So 12 to the negative first power would be 1 over 12, and 9 to the negative first power would be 1 over 9. So now 56 to the 3/4 power, 8 to the 3/4 power. Now, this one is a little mean, I'm not going to lie. Technically speaking, since they are both raised to the 3/4 power, I can put the 3/4 power back outside and divide what's inside. So because they have the exact same exponent, this does not happen very often, but because they both had the exact same exponent, I actually can pull that exponent back out and then take 56 divided by 8. This last one, it's 8 to the 1st over 8 to the 1/9. Anytime you're dividing, you can subtract if you have the exact same base, and it's always top minus the bottom. So this could be 8 to the 9/9 over 8 to the 1/9, which would make 8 to the 8/9. Simplifying. Now, this goes back to the factor tree stuff, and this goes back to, we're going to talk about if you have two, you can go either direction on this. If you multiply two radicals with the same root, you actually can bring them together. For instance, the square root of 3 times the square root of 5 would equal the square root of 15. Notice that I multiplied the radicands together. So the 3 on the inside and the 5 on the inside can be multiplied together, but this only applies if you have the same root. Now, same with this one. If I'm dividing, okay, I technically can divide it into the radical of the top and the radical of the bottom, and this can go either direction. So if I have the same radical on top and bottom, I actually can combine them into one radical if I wanted to. So the cube root of 4 times the cube root of 128. I can combine this into one radical by multiplying. They have the exact same index or the exact same root. So then 4 times 128 is 512. Now, let's talk about simplifying here. We haven't talked much about this. If I do a factor tree for 512, so let me get a factor tree out here. And this one is a fairly long tree because there's a lot of 2's. All right. I want the cube root. What that means, when you did the square root, you needed pairs. So when you're doing a cube root, you actually need 3 of a kind. So 3 2's, another 3 2's, and another 3 2's. So the cube root of 512 actually is 2 times 2 times 2, which is 8. Next one, because these are the same radical, I can take the 5th root of 192 divided by 6. Now, 192 divided by 6 is 32. So now I want the 5th root of 32. I'm going to do a tree just to show you this, but the 5th root of 32 is actually going to be 2 if you typed it in your calculator. But let me show you why. 2 times 16, 2 times 8, 2 times 4, 2 times 2. It's a 5th root. So you need 5 in order to come out of the radical. Well, there are 5 2's and no singles. So therefore, the 5th root of 32 is 2. Expression involving radicals with index n is in simplest form when the following 3 conditions. No radicands contain fractions. No radicands have perfect nth root powers or factors other than 1. And no radicals appear in the denominator of a fraction. To meet the last 2, you have to do what's called rationalize the denominator by multiplying the expression by the appropriate form of 1 that eliminates the radical from the denominator. Here's what I'm going to say this more in, I'll say in English here, because some of you I'm sure read that and don't understand what I just read. If you have a fraction, you can't have a radical under a, you can't have a fraction under a radical, and you can't have a radical in the denominator. If you have either one of those, you have to fix it. You have to rationalize the denominator. So no fractions, no perfect nth power factors, and no radicals in the denominator. So here we go. This is the simplest form that we just talked about. So I want to break this down. 5 times 100, which is 5 times 20, which is 2 times 10, which is 2 times 5. Now, I need cube roots. Cube root means 5 of a kind. So there's one, or excuse me, cube root means 3 of a kind. So there are 3 5s. They get to come out. And there are 2 that are, there's not enough. There's not enough 2's to get a cube root. So cube root of 2 times 2 would be 4. Now, you want to know what the most common mistake is? I'm going to circle it. I'm going to talk about it. I'm going to star it. When writing your answer, the root still needs to be a cube root. A lot of people are going to leave that as a square root, and it's not. It's a cube root. So the answer to this question is 5, cube root of 4. Let me do a factor tree on the next one, see if you get better at this. So 2 times 18, 2 times 9, 3 times 3. Now, I'm looking for 4 of a kind. So ultimately, this one does not simplify. There is not enough. Okay, the 4th root of 36 stays as the 4th root of 36 because ultimately there's only 2 3's and there's only 2 2's. So as you are doing this question, you need 4 of a kind. A bunch of people, when they see this question, are going to think, well, the answer should be 6. And yes, the square root of 36 is 6, but the 4th root of 36 does not change. So next one. All right, so now we got to start talking about fractions. And here's where things really start getting tough for people. Anytime you have a fraction inside of a radical, you should always think about simplifying the inside first. Well, 2/5 doesn't simplify, so that's no help. Square root of 2 over the square root of 5. That doesn't help much either because the square root of 2 isn't an even, isn't an integer, and the square root of 5 is not an integer. So the next step, and here's where things start really getting complicated. Anytime you have a radical on the bottom of the fraction, you're going to need to multiply the top and the bottom of the fraction to eliminate the radical. If it is a square root, you need pairs. Currently, you have 1 5 under the radical. So I need to multiply by 5 to the first. Because here's what happens. And again, you may or may not show this step. But the square root of 5 times the square root of 5 is the square root of 5 squared. And because you have a square root of something being squared, they cancel out and just make 5. So now, multiplying across the top, square root of 2 times the square root of 5 is the square root of 10. You cannot simplify something that's inside a radical with something that is outside a radical, so you are done. You have now finished what you need to do. Next one, 1/7 doesn't simplify. So now I do the cube root of 1 over the cube root of 7. Well, the cube root of 1 is actually 1. So again, anytime you can eliminate a radical, you should do that. So the cube root of 1 is 1. But I still have a radical on the bottom of the fraction. I'm not allowed to have a radical in the denominator. I'm looking for a cube root. There's currently 1/7. So I need to multiply by the cube root, and I need to get somewhere where I have enough to get rid of the radical. So I need 2 more 7's. So the denominator is now the cube root of 7 cubed, which is just 7. The numerator at the top is 1 times the cube root of 7 squared, which makes the cube root of 49. Anytime you have a radical and it's a fraction, you need to eliminate the radical in the denominator. So continuing here, the 4th root of 19, 4th root of 4. Now I'm going to write this because ultimately if it was a chance to simplify, I could simplify with the 19 and the 4, but you can't. So therefore, the only other step now is to go ahead and multiply to simplify. The 4th root of 19 and the 4th root of 2 squared. Now, some of you are probably looking at that going, what are you talking about? Remember, I want to come up with 4 of a kind, and since there's already 2 2's in 4, then I only need to multiply by 2 more 2's. So go ahead and break stuff down if it's possible so that you don't need to multiply by 4 to the 3rd power. It's only going to cause more issues later. So that makes a bottom of 4, 2 to the 4ths, which makes just 2. So now it's about getting the numerator. 4th root of 19 times 2 squared. So 19 times 4 is 76, and that is your answer. So the next one, I have the 5th root of 3 and the 5th root of 4. Now the 4 is the same. We just did this in the last problem. 4 is the same as 2 squared. So when I multiply, now I don't need to multiply by quite as many. I need 5 of a kind. I currently have 2 2's. So I'm going to multiply by 2 cubed. So now I have the 5th root of 2 to the 5th, which is just 2. The top, 2 cubed times 3 would be the 5th root of 24, and that is your answer. Continuing with the fractions now, a denominator that has a sum or a difference. So again, we're talking about the bottom of the fraction. If the bottom of the fraction is a binomial, so if the bottom of the fraction is, let's say, 3 plus square root of 2, if you ever have a radical in the bottom of a fraction and the bottom is a binomial, you need to multiply by what's known as the conjugate. The conjugate would be the same binomial, opposite signed. So notice a root b plus c root d. The conjugate would be a root b minus c root d. So anytime you have a radical, and what you multiply the bottom by, you would also have to multiply the top by. And we'll get into that when we actually have a problem here in just a second. But if you have a radical in the bottom of a fraction, and it's a binomial, it's no longer a single term like it has been in all the other examples, you are going to have to multiply by what is known as the conjugate. So here we go. 3 is being divided by 6 minus the square root of 2. 6 minus the square root of 2 is a binomial. So I need to multiply by the conjugate. The conjugate is 6 plus the square root of 2. Now, let's simplify the bottom first. So FOIL, 6 times 6 is 36. 6 times the square root of 2. 6 times a negative square root of 2. And negative square root of 2 times positive square root of 2 would be negative square root of 4. The middle will always cancel, and the last one will always be a perfect square. And so the denominator in this case is 34. Now, distribute the top. I end up getting 18 plus 3 square roots of 2. Now, if there was something that was divisible into all three, meaning 18, 3, and 34, I would simplify. If there's not, then that's the answer. That's as far as I can go. So if you have a fraction that has a radical on the bottom and the bottom is a binomial, you need to multiply by the conjugate. Your homework assignment is out of the book. Good luck. This is a more challenging one. Please make sure that you're doing this. Please make sure that you're going over your answers correctly. And please make sure you're talking to your teacher. And if you have any questions, make sure you ask. Good luck.